I will take you to three scientists, which were awarded the Nobel Prize in 2022. His work was published in 1972, and here you are seeing the picture of these three institutes which have Allen aspect. John is a lawyer. John Closer is a great institution and he did major work, while other institutions made some improvements in his work, and there we have it. A simplified statement of the Nobel Prize he won is that the universe is not locally real. Our universe is not locally real. Now this is a phenomenon that proves Einstein's theories wrong. It is not the whole theory, but it disproves some such things on which Einstein debated a lot in his life. Einstein always used to say that he is happy with quantum mechanics, that it is not perfect, and today quantum mechanics has told the knowledge stand that it is gradually increasing its influence and proving some of Einstein's theories wrong. Which we are going to discuss in this video, but first we have to discuss localization. What is local? In the language of science, in the language of physics, although many have worked on localization and there are many definitions on it, but here I want to give you a technical definition, which is called cause and fact does not move faster. The light, and if you want to see it in simplified form, then anything is adapted to its local environment. His effect is from his local environment. So if this brain is lying here, I am in its local environment and I can change its spin, its direction. For example, you leg a switch which is in our galaxy and that switch is connected one way or the other from a bulb which is in another galaxy. And if I turn that switch on off on OFF and at the same time the power in another galaxy also starts on OFF on off, then it is possible not there. Because this valuation is from Einstein's speed of light limit? Because information cannot travel faster than the speed of flight from one place to another, then how can information travel this much distance of millions of years in an instant? So here we will see the veins, but now we come to another word called real vein. There was a lot of debate even on the word whether things are real. Scientists worked a lot on this, but now we are trying to see the reality from the point of view of science. In the 19th century, the blameless olive school of thought was one led by Einstein, who spoke of a deterministic religion, while the other school, Neil, was much needed, which took people towards quantum mechanics. Einstein was of the opinion that all the things we see, such as the Earth, Sun, stars, electrons, protons, neutrons, are all those things which have defined properties. Whether you merge them or not, their properties will remain the same. Whether I see this mind or not, its color will remain white. If a car is in the forest, it has a blue color, but even if we go and see it, its color will be blue. It cannot happen that when we look, this brain is of white color, and when we face the other side, then the color of this brain becomes red. Einstein believed this, but on the other hand, the other school of thought was saying that if you go to a very small level, things start happening anti-really. It was an anti-realist block. Neil was at the forefront in this, and he used to say that if you toss a coin to Coswin, then in what state is he at the moment? Will there be a moon or a star on it? At this time the probability of the arrival of both the moon and the star when it is in the air is equal. But when it falls on the ground and now the mayor takes care of it, then you can tell and determine that the moon has come. Otherwise, you have random when it bounces up, but deterministic when it bounces. You make his main mate. And these are all things that are probabilities of his outcome or his or her possible status. It is defined in the wave function. We know that after Neil Bohr, Gar and Heisenberg and many such scientists did not come who did a lot of work in quantum mechanics. Did the same experiment. It was a thought experiment in which a cat was locked in a box and there was a mechanism in that box, which was a radioactive mechanism that could kill the cat. Now is the cat alive or dead in the box? You have to guess from outside whether there is any sound coming from the compartment. It is exactly like this lying box. And neither give you any other information, so at this time the cat near you is alive or dead. There are both cat statuses near you. Both have probability, both are in superposition. The cat in your house can be alive and can also die. But to check this you need to give me main and you need to open the box. And when you open the box, its wave function clapped. Now it's alive, then you know it's alive with probability 1, and if it's dead you know it's now dead with probability 1. Einstein had a lot of trouble with these things. He wrote a very famous paper in 1935, which is called the EPR paper, and it used to map out a lot of such question lines that it didn't say too many things that didn't meet quantum mechanics. He thought that quantum mechanics is fine, but there are many things in it that we do not know about. We need to get more information. This theory is not complete, it needs to be completed, and the phenomenon that troubled him the most was his internals. Einstein couldn't stand entanglement, so what is quantum entanglement? If you see in your everyday life and you see an object like a ball rolling, then you will understand that some kind of force applied on it makes the thing spin because of the force. Things move because of force and because of external force. It is very important to have force while rotating. But when we go to the smallest level, when we go to the quantum level, when we go to the atomic level, then there we see something more phenomenal. I have a small ball, and from this ball we will get two balls. Now this ball was kept on us. That is, there was neither any kind of spin nor motion in it. So when two will meet and once is going towards the right side, then the other will be going towards the left side, because we have to conserve the hotel momentum of the system. Law is coming in our way. So whatever you have, two balls are made from one ball. I am saying this to explain to you, one will go towards the right side and the other La Mahala will go towards the left side. Will this be their natural behavior, or if one starts moving clockwise, starts spinning, then the other will spin anti-clockwise, so that who will maintain the annular momentum? In that system? But if both balls that came from one ball and that ball were exactly the same, both balls start moving clockwise. So now that the annular momentum is no longer a concert, what do you think? You'll understand that from the outside the external force will apply. Some or the other force has acted on it, and because of this the spin of both these balls is the same. Their movements should not be the same. In the same way, when we tangle two particles in quantum mechanics, we connect them and then we take them away, whether I put them on the edge of this table or take two galaxies in it. Now, by taking the measurement of one particle, we will know about the measurement of the other particle about its state. The particle here is moving clockwise, so as soon as I take it, I will know that the other particle is moving anti-clockwise. It is possible that if I had taken the mayor here at some other time, then the particle which was here would have been seen anti-clockwise. Me, because there is a probability stick chance here, then another particle rotates again, so by taking my mate of this particle, we could know about the particle which is away from us for 1,000,000 years, on which I stand had a kind of problem, because this violation the locality is that the particle is very far away and we are changing the state of the parameter of that particle from a very distant thing. Now nothing is moving faster than the speed of light, then from here to there. Till how does the information move instantly? How do we get its information? I get to know by ordering it. Einstein had to spend a lot on this. He used to say that when these particles were cut, then at the same time he had made his mind set, had made his mind. I am producing this non-technical that one particle will move clockwise and the other will move anti-clockwise. When quantum mechanics is saying that we did not create this particle. Both types of spin are present in it. But when we measure it, if that spin is anti-clockwise, then its wave function will collapse, and we will come to know, because I mentally and with it the second wave function will also collapse, because we will know that now you know everything about the vibrations of locality. Then who was right? Einstein thought that those variables were hidden variables. When they are strong and make their mind set, then when we remove them, then the connection between them is due to the hidden variable, and Einstein could not describe that hidden variable, so now we have one side wave is the function and on the other side are the hidden variables. There is a competition between them and we have to test them experimentally whether the hidden variables are describing you correctly or the wave function is describing you correctly, and John Bell comes for this. In 1964 he wrote one of his research papers, Irish physicist, and he gave us the Bell inequality Zobel. Called rum. He used to do this work in the year and he proposed many such mates with the help of which we could get an idea. So coming to this experiment through which we can now tell whether our universe is locally real or our universal is not locally real. In this experiment we will take these tangled photons. So your question would be, what is a photon? A photon is an energy packet of light. I am showing you photon here in the form of a wave, and it has different characteristics properties, one of which is polarization. So the photon is vertically polarized. This means that its oscillation is going from top to bottom. There is a vertical line. Horizontal line. If it is polarized, then it means that its oscillation is going around the axis, and mixed photos are also there. That is, they are in between vertical and horizontal polarization. I'm showing you the movement of a photon here, so it's. Next we applied a filter, and we applied that filter of vertical, so the filter we have, this film, also allows vertically polarized photons to pass through. Its function is that whatever vertically polarized photons can pass through the vertically polarized filter. The rest didn't stop. And if we have horizontally polarized filters, then those horizontal photos, I'm using horizontal photos for ease. Doing live in the middle of polarization, they will let horizontal photos go. I have two filters now. An experiment has a vertical filter and a horizontal filter. You will see the arrow above the vertical filter and you will see the arrow towards you on the horizontal filter. In between, different types of photons are passing through, there are mixed photos and there are vertical photons and photons too. So when you have the first filter, it will only let the vertical photons go ahead and the second filter will not let them go because it only wants the photos, so the observer we have is at the second side of the second filter. He will not see anything. He will see darkness because light is not passing through. I have two films here and you can see that if you keep a vertical and horizontal film above and keep it below, you will see darkness, but if you put a third film in between, whose polarization is slightly different, then you will feel the light coming. And you will see less darkness. We do this experiment here, where we put a film at a polarization angle of 45. We have the same situation again. Light is coming to us on which there are different types of photons and vertical photons pass through. When vertical photos go ahead and they try to pass through 45 polarization, then here we are taking additional, and we know that when we go to quantum level and take additional or measurement, then their properties change. She goes. Whenever we accept this, the properties of things change. They do not stay in that state but go to all the states. So when I consider these photons skyrmions, then their polarization will change. As soon as they pass through the 45K filter, their polarization will change. Now some such photons must have happened, they must have come to us. The risk will be horizontal Leland, and that 90K, i.e. the last filter, which is our horizontal filter, they will pass through it and we will start seeing light. We in an additional or mentally? Now I am taking this experiment to a bigger level because now we are going to discuss the experiment on the basis of which this Nobel Prize was given. I have two observers here. One's name is LS and one's name is Bob. Both of them have their own polarizing array films. Their polarization keeps on changing. So where you will see vertical arrow. This means that it is vertically polarized, and where you see the feet pointing towards you, it is horizontally polarized, and where you see the arrow moving. This means that their polarization is variable. Change is taking place. There is a source in between and tangled photons are produced. From the source, if one vertically polarized electron is produced from this source, then the other vertically opposite, i.e. horizontally polarized photon will emerge, because we remember, right? Told two balls. If one spins clockwise, the other will spin anticlockwise. In the same way, the polarization of the photon should be opposite so that we keep the loss intact. I have two filters here on one side. We put filters on both sides. Vertical and then Su-town have been produced. Now a vertical. If the photon will come towards a vertical fielder, then one or the other of these two will say that he has received the photon. In this status, he has now started rotating his film. Randomly, when they started rotating their film randomly, then Mukti photos are coming. Their agreement is happening and sometimes their disagreement is happening. We want to plot this thing, and in what way are we trying to plot it? We are trying to plot between agreement and disagreement, so I am also showing you the graph here. We have both the film NTA line in this condition, i.e. one is vertical and the other is horizontal, and in the middle we have photon are produced. When the photons will be produced and come to this side, if vertical comes towards the hotel and horizontal comes towards the hotel, then both will say yes, we got the photon, but if it comes in reverse, then both will say at the same time, no, we did not get the photo. So both will always have an agreement. Both will be in the agreement. K photon has come. Or will it remain in this agreement also that photon did not come, but we changed their alignment now, and the alignment which we had done 90's alignment in the middle, that is, they were anti-aligned, now if you are going to align, you will see that the angle is 0. In this condition, when photons travel in both directions, the two observers will be in disagreement. One will feel that the photon has come and the other will say that the photon is not there. You are clearly getting to know from the animation. And if the photon of the other has come, then the second will say the first will say that the photon has not come, and we will start plotting this agreement and disagreement. The sign places believe that if our land and our world is real, local is real, so this graph should appear in a straight line. And they thought that it would also come like this. But when John Closer wrote his research paper in 1972, he didn't show a straight line. He said that quantum mechanics says that an S will get done when practically this experiment was done, which was a very difficult experiment, and I told you very simply, so we got it done. You see, the S curve that came to us was exactly what John Closer described in his research paper. This means that our universe is not locally real. Our universe is not deterministic, it is the way we see the universe. Those who narrate the reality need improvement. Einstein's deterministic model of universe is now failing, and quantum mechanics' probabilistic model of universe is now slowly gaining ground. There are many applications of this discovery as well. If we talk about it, i.e. entanglement, then we are going to use it a lot in quantum computing, because we are working on quantum computers that mainframe computers can be mixed on mainly quantum computers, and they go far beyond classical computers. This phenomenon will also be used a lot in quantum cryptography. It is being done in the future and is still being done. Let me also tell you here that one thing needs to be taken care of so that we do not understand this from this video. You should not worry at all that information moves faster than the speed of light, because there are two random nerves here. If photons are being generated randomly from a source, then we do not know the fate of which photon will be generated, its polarization. There is a lot of randomness, and the polarization of the observer on the other side is also random. You saw that the polarization was moving, the alignment was moving. So here too there is a lot of random noise, and because of these two random noises, we cannot send information on these carriers from one place to another, nor can we encode and decode it. There is a lot of technical problem. Because of this phenomenon is not yet used for transmission for information movement, and the speed of light is in its place in these texts. So on one hand we have negated Einstein's deterministic point of reason, on the other hand, we retained Einstein's limit of speed of flight, and in this Fermino also we told that Einstein's limit still exists and there is nothing that is making him a seat. So I hope that Einstein will be sad on one side and maybe smiling on the other side, so we should also make a wave function of this and see what are the states in which Einstein can be at this time. I hope you have liked this video.